I'm asked to find the x-intercept. You have to be careful. Sometimes it asks you for the vertex. Sometimes it asks you for the y-intercept. This time it's asking me for the x-intercept. The x-intercept is at 3, 0, and 5, 0. The vertex would be at 4, -1. This is the vertex. If it wanted the y-intercept, I would just enter a 0 in for the x, and that would give me 0 minus 4, and I would type it in the calculator, -1, and that would give me the y-intercept. But it's not asking that. This one, what's it asking for? Coordinates of the vertex. Coordinates of the vertex. We're going to use this algorithm called opposite same. We're going to ask for the vertex of a quadratic, so we're going to take the opposite of the -2, and that's going to give me 2, and the same as the -4. We don't use the calculator or anything, it's just direct observation. Domain. So the domain is the x value. Let's look at this real quick. Domain range is going to be x, y's. X comes before y in the alphabet, D comes before I. The domain represents the x values. The x values, I know it looks like it's going down really far, but it's also going to the right and left really far. So the domain for this is going to be -infinity to positive infinity. I start from the left, and there's always going to be an x value. I go to the right, there's always going to be an x value. So that's the domain. The range, however, is the y values. And notice the y values start from very low. The y values start from -infinity, and they stop up here at the y value of the vertex, which is at 3. So the y values stop at 3. So the range is not going to be from -infinity to positive infinity. That's the domain. The range is going to be from -infinity because it starts really low and ends at positive 1, 2, 3, the highest y value. Now that is a closed circle, and for this range, we're going to put a bracket. So that would be domain, domain, domain. It would be choice B. Opposite same, the vertex is going to be located at -3, -3. So if I have an x-axis, it's going to go left and down. So the vertex would be over there. It has a 2 in front, not a -2, so that means it would be concave up. This one goes left and down, this one goes left and up, it can't be A. It goes left and down, that's good, but it's concave down, no good. This one is concave down, no good. Has to be choice C. Find the vertex, once again, we're going to use opposite same. So I'm going to go ahead and take the opposite of that, -4, that's going to be +4, and the same as that, -8. So the vertex is going to be 4, -8. That would give me choice A. Find the vertex. Now, this one, we can't use opposite same. We're not going to use that. We're going to go mode 5-3 it. Mode 5-3. And we're going to type in the coefficients. 9, then hit equals, then -162, hit equals, and then 737, and hit equals. So after I'm mode 5-3, I'm going to type in 9 equals, -162 equals, 737 equals. Then I'm going to hit equals, and I'm going to get an x value 1, x sub 1 value. And that's going to give me that. And that's not what I'm looking for. I'm looking for the vertex. This is a root, and it's an imaginary root. Then x sub 2 will equal the other version of that. 9 minus 2 root 2 over 3i. I'm not looking for that. The vertex is located at the x val min. And notice in this case, the x val min is 9. Then you hit equals again, and it'll give you the y val min. And that is 8. Don't change these. The vertex is going to be located at 9, 8. In that order. Choice C. Use the technology if you're allowed. This one, I'm going to use the tech. Again, I'm going to mode 5-3 it. I'm going to type in -3. I'm going to type in -2. I'm going to type in -4. Now, I know it's going to be concave down, so I can immediately get rid of B. So I have a choice between A, C, or D. I also know the y-intercept is going to be -4. So that looks like it goes through -4. That one looks like it goes through -4. This one goes through +4. It has to go through -4, so it can't be A. I can actually make a educated guess. Because it is a -3 out front, that means it's going to be really narrow. So that one's kind of fat. This one would be 1/3, or -1/3 x squared out front. This one is really narrow, so that would be -3 x squared for the front number. But I'm going to mode 5-3 it anyway to get the actual vertex to see if it went left and down versus right or down. Now try to recall. When I do my mode 5-3 for this particular problem, I'm looking for my x val min and my y val min just to locate where that vertex is. So when I type that in, I get -1/3 for my x val min. I get -1/3 for my x val min. That means I'm going to go left. So right now I know it can't be this one. The vertex went right. And then I'm going to get -11/3 for my y val min. So that means it went down. This one went down, but this one went left and down. So it has to be choice C. This one I got a lot of words, and then it gives me the equation. So I like when it gives me the equation. And it asks, when does the object hit the ground? So here's the picture of this. An object is thrown from a height of 160 feet. So that means you're going to have a building or a cliff that's 160 feet off the ground. Then you're going to throw this thing upward, and then it's going to fall and hit the ground. When you do that, the initial velocity is going to be 144. That's the middle number. This initial height, 160, that's the last number. And this -16 is how stuff falls in America. Because in America, we use the standard system where feet, we use feet, whereas in other countries, they would use meters instead of feet. So this one here is a feet problem. And that's -16. In other countries, the meters, it would be -4.9, I believe, but not in this problem. And it's asking me when the object hits the ground. Now, the object, if I were to have the actual upside-down parabola, would have a negative x value and a positive x value. And I don't know what this positive x value is or the negative x value, but we can find those out by mode 5-3. Now, my calculator gives me an x1, and that's what I'm looking for, an x1 or an x2. x1 of 10 and an x2 of -1. So you can't hit the ground at -1 seconds. It's true mathematically, but it's not true in reality. So it goes up, it's in the air for a while, and it hits the ground after 10 seconds. So that thing was launched in the air for a long time. And notice my choice is over there. If I were to keep hitting the equals button, it would give me how long it took to reach a maximum height. And that would be my x-val min, or x-val max. And that would be 4.5 seconds to reach that height. And that height is actually 484. Notice it's higher than 160 and went up really high. And it hits the ground, it is 0 feet high, but it took 10 seconds to get over there. So that's time, and this is height. Another problem, this time it's asking for the maximum height. So slightly different drawing. The building now is only 60 feet high. It's launched with the speed, initial velocity of 96 feet per second. It goes up and then hits the ground. It does not want to know when it hits the ground. It does want to know how high it gets. It does not want to know how long it takes to reach that height. This is going to be a mode 5-3 problem again. We're going to type in the coefficients negative 16, 96, and 60. Now once I type that in, I get an x-val max this time, an x-val maximum of 3. That means it takes 3 seconds to reach that height. And then I get a y-val max. And that's what it's asking for. The y-value maximum equals 204 feet. That means it takes 3 seconds to reach 204 feet. And it just so happens to be one of my solutions. Use synthetic division, no real calculator use for this. I actually have to do it, so I'm going to put the opposite in the backwards box. Write down the coefficients. So after I do the process, I add the negative 2 to the 0, that gives me negative 2. I multiply, that gives me positive 10. 10 minus 6 is 4. Negative 5 times 4 is negative 20. 25 minus 20 is 5. Negative 5 times negative 5 is negative 25. My remainder is 0. So what this means now is negative 2x squared. Notice it went from an x cubed to an x squared. You divided it by an x. That's going to break it down by 1 exponential power. Plus 4x plus 5. My answer is D. Put my 0. My coefficients are the first, the backwards box is the opposite of that negative 2. Then I put the coefficients. I have to remember the placeholder for the x term. There is no x term, so I have to put a 0 in for that x term. Going to do the process. I add them. I multiply them. I add them. That gives me 4. I multiply them. That gives me 8. 8 minus 10 is negative 2. I multiply them. Negative 4. I add them. Negative 4. I multiply them. I get negative 8. 15 minus 8, I believe, is 7. So my remainder is going to equal 7. Here's what this means. It went from x to the 4th. It's going to drop down to 3x cubed plus 4x squared minus 2x minus 4 plus this 7 over the original denominator, x minus 2. So notice I add. It looks like it's going to be choice C. 3, 4, negative 2, negative 4, 7 over x minus 2. A couple of ways to do this. They want to know if 2 is an answer. If they want to know the remainder, then I have to do synthetic or plug it in. For this one, I'm just going to mode 5, 4. Do realize it's to the 3rd power, so I'm going to mode 5, 4. My coefficients would be negative 8, hit equals 1, hit equals negative 3, hit equals, hit 3, then hit equals a couple more times, and it'll give you an x1 value, an x2 value, and an x3 value. And I'm looking for one of those values to be 2. I want one of those to be 2. If one of those is 2, my answer will be yes. If I don't get a number of 2 for any of these, my answer would be no. And we'll notice that none of my answers have a 2 in it, so my answer is no, after I did the mode 5-4 process. Fine if that's a 0 to that. So again, I'm going to hit mode 5-4. My coefficients are going to be 1 equals 4. Ooh, you can't mode 5-4 it. I have to go to the white calculator. White calculator, another Casio. In order to do this, we have to hit menu minus. So we turn it on, we hit the menu button, and over here is the minus button. And now, I want to choose a polynomial. That's a 4th degree polynomial, so I'm going to choose number 2 for polynomial. Then it wants me to figure out what the degree is. Notice, the degree is 4, so I'm going to hit 4. And then, just like mode 5-3, we type in the coefficients. So I'm going to type in the 1, I'm going to type in a 0 because there's no x third term. Then I'm going to type in a 4. Then I'm going to type in a 0 because there's no x term. And then I'm going to type in a negative 45. When I hit equals, it's going to give me 4 answers, and one of the answers is root 3. I'm sorry, root 5. Well, that's not what it's asking. Another answer is negative root 5. Again, that's not what it's asking. 3i. I know it says 3, but it doesn't ask for 3i. And the last answer is negative 3i. So my answer to this is going to be no. Again, if it's to the 4th degree, we can use the white calculator, and you're going to hit menu, little small minus symbol, and that'll bring up the solver for this particular type of equation. X to the 3rd, we can do mode 5-4 on the blue calculator. On the blue calculator. Then you're going to type in 1 equals, negative 5 equals, 11 equals, negative 15 equals. Mode 5, 4. Notice it's x third. You can see that it's an x to the 3rd. When I get to that screen, I'm going to type in those coefficients of 1, then negative 3, then 11, then negative 15. It'll give me my x sub 1, 1.7. It'll give me my x sub 2, 0.64. 0.64 minus. So that means the answer to that one is no. I did not get positive 3. Notice, if the factor is x minus 3, you're looking for x equals 3 as a solution. And I got x equals 1.7. X sub 2 equals 0.647. X sub 3 equals 0.647 again. So the answer is no. X to the fourth wants to know if this is a factor of that equation. I'm going to look to see if x equals -2 is a 0. And using the white calculator, I'm going to hit menu and then the minus button. It's a polynomial, so I'm going to click 2. It's a 4th degree polynomial, so I'm going to choose 4. And my coefficients are 5, 9, -2, 1, and 0. A lot of numbers, so I'm going to type them in as accurately as I can. 5, 9, -2, 1, and 4. And one of my answers is 0.7. Another answer is -1.9. Another one is 0.4 plus 5i, 0.5i. 0.4 minus 0.5i. Nope, that is not a solution. Wants to know if 5 is a 0. Oh, it tells me 5 is 0, then wants me to factor it. I'm going to mode 5 for it on the blue calculator. I'm going to mode 5 for this one on the blue calculator. For this one, when I do it, I'm going to change the answer. So it's going to give me an x1 equals, it's going to give me an x2 equals, and it's going to give me an x sub 3 equals when I mode 5 for it. I hit mode, I hit 5, I hit 4, because it's x cubed. And I'm going to type in the coefficients of 1, -2, -25, and then 50. So my x sub 1 is -5. My x sub 2 is 5. My x sub 3 is 2. So let's see if I have that right again. It was -5. It was 5. And notice they gave me that. And it was 2. With that given information, I can now factor it. If x equals -5 is an answer or 0, x plus 5 is going to be a factor. X minus 5 is going to be a factor. And x minus 2 is going to be a factor. It doesn't have to be in that order. So I'm looking for a -5, -5, a +5, and a -2. There it is. It is choice D. I'm going to do the same thing for number 17, but notice it gives me the answers. And then I have to figure out what the factors are. So I did the mode 5-4 on the blue Casio, and I got x equals 3. That means the factor is going to be x minus 3. I got x equals 1/2. That means the opposite divided by 2 is multiplying by 2. So it's going to give me 2x. The opposite of +1 is -1. There's another linear factor. This one has a negative, so it's a little bit of a rebel. So it's going to give me 2x. The opposite of -1 is +1. So I have an answer of 3, -1/2, and 1/2. Both of these meet that criteria. But notice they're trying to trick me with the factors. I need that leading coefficient of 2 out front. Now for number 19, I don't have to use the calculator. It already gives me the 0 at -3, so that means x plus 3 is going to be a 0. X plus 1 is going to be a 0. X minus 1. And then x minus 2. Let's see, it can't be the one with the leading x. It can't be the one with the leading negative. We have x plus 3. Can't be that one. I think we're stuck with just choice C. X plus 3, x plus 1, x minus 1, x minus 2. And behavior, a quick note to know, if it's y equals x to the odd, it's a positive number up front. It's going to be down on the left and up on the right. If it's a positive x to the odd. If it's y equals a negative x to the odd, well, that's going to be a horse of a different color. What's going to happen in that situation is it's going to switch. It's going to reflect. It's going to be up on the left and down on the right. And let's see, this is negative x to the odd. So it's going to be up on the left, and down on the right. So that would be choice A. If I were to go a little bit further, y equals x to the even. Notice it is positive, and the exponent is even. Then it's going to look like a parabola. It's going to be this up on the left, up on the right. Notice our drawings don't have any middle part. And if it were y equals negative x to the odd, well, that would go ahead and switch the drawing. I'm sorry, negative x to the even. That would switch the drawing from up to down. And that's a pretty good note to have at your disposal. Negative x to the third is going to be negative x to the odd, up on the left, down on the right. So that's going to be choice A. 2.56, that's a positive. X to the fourth, positive, even, x to the even is going to be up. So that's going to be choice B, up. Notice it's a positive out front, and that's an x to the first, and that's an x to the second. So it's basically going to be a skinny 2x cubed. X cubed is down on the left, up on the right. That's going to give me either choice A or choice D. It cannot be C, because that's the wrong end behavior. Now I'm going to inspect the zeros. It has a 0 at 0. So that one goes through 0. That's good. Oh, that one goes through 0 as well. It's still a toss-up. Now, the factor is x minus 2. That means it's going to go at positive 2 is going to be a 0. That one doesn't have a 0 at positive 2. It has a 0 at negative 2. And what's nice is at positive 2, it bounces. That's what that 2 means there. That means multiplicity 2. And multiplicity 2 is going to touch and turn.